We have photographed the surface of Pluto, landed rovers on Mars, dropped a probe through Saturn's clouds. We treat our own star like a fixed lamp in the ceiling, something that will simply burn forever. It will not. The sun is already halfway through its life, and its death has a schedule. What is strange is not that it ends. What is strange is how it ends. A slow murder of Earth, 1 billion years before the sun itself dies, then a monster the size of our orbit, then a corpse that outlasts the universe. Subscribe and let's watch our star die properly. Right now, at this second, the sun is fusing 600 million tons of hydrogen into helium every second. It has been doing this for 4.5 billion years, and it has roughly 5 billion left. That sounds comforting. It should not be. Astronomers classify our sun as a G-type main sequence star, a middle-aged furnace, perfectly stable, boringly predictable. NASA's Solar Dynamics Observatory has watched it in extreme ultraviolet since 2010, and the numbers barely twitch. But a furnace this vast is still a furnace with a bottom. Fuel is finite. And here's where it gets strange. The sun does not need to run out of hydrogen to kill us. It only needs to get slightly brighter. And it is already doing that right now as you breathe. The clock on Earth is shorter than the clock on the sun. In about 1 billion years, long before the sun swells, long before anything dramatic, Earth ends. As the sun ages, its core slowly contracts, fusion accelerates, and its luminosity creeps upward by roughly 10%. 10%. That sounds trivial. It is apocalyptic. Climate models by James Casting and later refined by NASA's Goddard Institute show that this brightening is enough to trigger a runaway greenhouse. Oceans evaporate into the upper atmosphere. Water vapor, itself a greenhouse gas, traps more heat. Ultraviolet light rips those water molecules apart, and the hydrogen bleeds off into space. Earth becomes Venus. No oceans, no rain, a dry, sterilized rock under a sun that has barely aged. Life ends first. The sun does not even notice. And this is only the warm-up, because the real death of our star has not started yet. Around 5 billion years from now, the sun's core finally runs out of hydrogen. What happens next is not an explosion. It is worse. It is a swelling. With no fusion to push outward, the core collapses under its own gravity. And as it collapses, it heats. Hydrogen ignites in a thin shell around the dead core, and that shell burns furiously, dumping more energy into the outer layers than ever before. The sun begins to expand, and it does not stop. Peer-reviewed models by Schröder and Smith, published in monthly notices of the Royal Astronomical Society in 2008, calculate the endpoint precisely. The sun will swell to more than 200 times its current radius. Mercury, gone. Venus, gone. And Earth, already a dead cinder, is dragged inward by tidal friction and swallowed whole. Our planet ends inside our own star, but the sun is not finished growing. It is about to detonate. Deep inside the swollen red giant, something impossible is happening. The core, now a ball of helium ash, has been compressed to unimaginable densities. It is degenerate matter, packed so tightly that normal physics no longer applies. Pressure and temperature are decoupled, and then, in a moment, the temperature crosses 100 million degrees. Helium ignites. In a normal star, this would be gradual. In degenerate matter, it is not. In roughly a few seconds, the entire core detonates in what astronomers call the helium flash, briefly releasing energy comparable to billions of suns, a burst so violent it rivals an entire galaxy of ordinary stars. And yet, from the outside, you would see almost nothing. The outer envelope absorbs the shock. The sun barely flinches. The most violent event in our star's life is hidden inside its own corpse. And then the shedding begins. After the helium flash, the sun becomes unstable. It pulses. Fusion shells flicker on and off around the shrinking core, and each pulse sends waves of energy outward. The outer layers, what is left of the sun's atmosphere, begin to lift off, not in an explosion, in a slow, majestic exhale. Stellar winds, hundreds of times stronger than today's solar wind, strip the sun of nearly half its mass. Layer by layer, the star sheds its own skin into space. Hydrogen, helium, carbon, oxygen, nitrogen, the very atoms that once made up sunlight and warmth and the air in your lungs, drift outward at tens of kilometers per second. The sun is undressing itself in front of the galaxy, and what those layers become next is one of the most beautiful and misleading objects in astronomy. The shells the sun sheds do not just drift away, they glow. Radiation from the exposed, ferociously hot core ionizes them from within, and they light up in ghostly greens, blues, and reds. Astronomers call this a planetary nebula, a name that is completely wrong. It has nothing to do with planets. William Herschel coined the term in the 1780s because, through his telescope, these objects looked like faint disks, like Uranus. The name stuck. What our sun will become resembles the Ring Nebula in Lyra, or the Helix Nebula in Aquarius, both photographed in extraordinary detail by Hubble. Vast, glowing, hollow shells of gas, light years across. And here is the strange part. They are temporary. A planetary nebula lasts only about 10,000 years before it fades and disperses. Our sun's most beautiful moment is the shortest. Everything visible about our star is about to disappear. The nebula fades. The winds die. And what is left in the center is the real corpse of the sun, a white dwarf. It is what the core has been building toward the entire time, exposed at last. Roughly the size of Earth, half the mass of the original sun. Surface temperature, 200,000 degrees Celsius, hotter than anything the sun ever produced while alive, and so dense that a single teaspoon of it would weigh several tons on Earth. No fusion, no fuel, just a naked, degenerate carbon-oxygen crystal. Astronomers have detected some already crystallizing using data from ESA's Gaia mission published in 2019. It sits there, glowing on residual heat alone, radiating slowly into the dark. It will cool for billions of years, then trillions. And here is where the story becomes truly cosmic, because the universe itself is not yet old enough to see what happens next. A white dwarf cools by radiating heat into empty space. But space is cold, and the dwarf is small, and thermodynamics is patient. Calculations by physicists, including Fred Adams and Gregory Laughlin, in their landmark paper on the far future of the universe, put the cooling time scale at roughly 1 quadrillion years, 1,000 trillion. Only then does the corpse of the sun fade to invisibility. It becomes a black dwarf, a cold, dark, dense cinder, drifting through a universe that has by then run out of star formation, run out of light, run out of almost everything. And here is the fact that should stop you. The universe is only 13.8 billion years old. Not a single black dwarf exists yet, anywhere. The sun's true final form is a state of matter the cosmos has never been old enough to produce. Our star's ending has not happened to anyone ever. There is one last twist, and it turns the whole story inside out. The atoms in your body, the calcium in your bones, the iron in your blood, the oxygen in every breath were forged inside stars that died exactly like this. Red giants that swelled shed their skins and left glowing nebulae behind. That gas seeded new clouds. Those clouds collapsed into new stars, new planets, new life. You are, quite literally, the recycled outer layers of dead suns. And when our sun sheds its own skin, it will do the same for whatever comes next. Some of those atoms will drift for 100 million years and end up in a new star system. Perhaps a new planet. Perhaps something that opens its eyes and looks up. Carl Sagan said we are star stuff. He was being modest. We are the exhaled breath of stars that died screaming. And so is everything that will ever come after us. The sun is not eternal. It is a furnace with a bottom, a life with a schedule, and an ending written in physics we already understand. Earth dies first. The sun swells, detonates, sheds, and cools into a corpse the universe has never been old enough to finish making. And every atom of it, every atom of us, keeps going. Which part of this death disturbs you most? The billion-year boiling of the oceans, the moment Earth is swallowed whole, or the black dwarf that cannot yet exist? Tell me below, and stay. There are darker places out there than a dying sun.